Hello, this is Jonathan Wood from Soft Circuits, and in this video I'd like to talk about implementing print and print preview in MFC. And we'll start by creating a new project, and it will be an MFC application, and we'll call it print test. And we're mostly going to accept the defaults, but I just want to show you of our options. In our advanced options, one of the options is printing and print preview, and the MFC wizard will implement some of that logic for us. So that's checked by default, and we'll just use that. And now we're going to go into the view class, and just so we have something to look at, we're going to go ahead and put some printing code in the onDraw method of the view class. Create a red pen. And a yellow brush. And select them into the device context. And when we're done, we need to select back the old ones. And I'm just going to draw a circle using the ellipse method, using that pen and brush. Okay, and there's some simple code, and let's go ahead and run that. And there's the circle that we just created, and what I want to show you is that we automatically have a print preview command based on that checkbox in the initial wizard when we created the application. Let's click on that, and that shows us basically what's going to happen if we try to print. And the first thing you'll notice is that circle is very small compared to the circle that we see on the in the regular window. And the reason for that is because this circle is drawn on the screen, and the screen has a resolution of maybe a dozen or so pixels per inch, while my printer is a laser printer, has 600 dots per inch, and so the mapping mode we're using is based on pixels. And so if we look at that, our circle is 250 minus 60. So 190 pixels, and on the printer that's not very much. So even though print preview and print are already implemented for us automatically, a little more work's done to have it make sense. And the way we're going to handle that, now there's a couple of ways to handle that, but the way we're going to do it for this is very simple. What we're going to do is use the _low English mapping mode. Now by default we use the _text mapping mode, and that's basically based on pixels, and the low English mapping mode is where each unit is mapped to 0.01 inch of the device we're writing on. So in other words, it's going to be more pixels on a high resolution device such as my printer, and it's going to be less pixels on a lower resolution device such as my screen. So we'll call set map mode and low metric. And notice also another difference about low metric is that our in our default mm_text mode, 0 is the top left corner of the screen, where with low metric it's at the bottom left. So our y coordinates are reversed, and so our coordinates are now based on inches. And let's run that. First of all, our circle's a little bigger, but that's just because we're using a different size. But now we go to the print preview, we'll see that our circle's a little more reasonable looking, a little closer to what we might expect based on the size of the circle on the screen. Now, one thing we should do here is the Windows needs to know how many pages we have, and it doesn't know that. So if we go to the on begin, or rather the on prepare printing, and one of the arguments is this p-info structure, and we can call set max page, and we'll set it to 1. And now if we run it, we've got the same thing again. Go to print preview, and you notice next page and previous page are disabled because it knows there's only one page. So that's a very simple way to implement printing and print preview. And now we're going to try something a little different. So I'm going to go ahead and create another project. This is also an MFC application, but we're going to call this one print test 2. And we know that by default we have the print and print preview feature checked, so we'll just go ahead and accept those. And we're going to go to our view. And once again, I need to create a little code here so we have something to view on the screen. Now I'm just selecting a system font, the default GUI font, and now I'm going to determine how high each line of text is. And I'll have IntelliSense if I uncomment the device context pointer. So I'll get the text metrics, and then line height is going to be equal to the character height plus the external leading. And finally, I can draw the content. And we're just going to draw 100 lines of text. Keep it real simple. And our y coordinate will increment the same height as our line, or rather of each line of text. Oops. And finally we'll call the text out method. Give us a little margin, use our y coordinate and our string, and we'll provide the length of the string. And then finally we do need to restore the DC by selecting the original font back in. And we'll go ahead and run that. And that's basically all we have. We're writing 100 lines, which is not going to fit in the window. So basically, it fills the full window with the lines of text using the current system GUI font. Now again, we can go to print preview, but well, we can't even see it here. That's our lines of text, and as with the circle before, you can see they're very small. And again, it's because of the different resolution between the screen and my printer. So there's a number of ways that this can be handled. One is, you notice in our first example with the circle, our drawing routines were in on draw, and we still use the same drawing routines even when we were printing. And that's kind of nice, because if our drawing routines are kind of complex, we only have to have them in one place in the code, and that allows us to not have to repeat that code, and anytime you make changes, have to make it be made in multiple places. So that's nice to do. But the other option is to actually have different code for printing than used to draw to the screen, and that's what I'm going to do in this example. And so first thing we're going to do is add some code into on begin printing. On begin printing is printed just as we're starting to print. And let me uncomment the arguments here. And I want to do a couple of things. First of all, we want to get the default GUI font from the system again, as we did when we printed to the screen. However, this time we want the font to be a little different size, as you recall, because we want it to be the right size for the printer. So I'm going to bypass MFC here and just kind of go straight to the regular API stuff. And we're going to start by getting that stock object again. And there's also an API called getObject, and it returns information on a GDI object. So in this case, we're passing a font, and we'll pass our font handle, and it's going to return a log font structure. So we tell it how big our data is, and of course a pointer to our log font structure, and that gives us a log font structure which we can use to create our final font. So we're going to accept all the settings in that, except we want to change the height. And so we can do that by setting it using a little calculation. Now if we call the device context, which now refers to our printer, because this is when we're printing, and we can call get device caps or capabilities, and pass res. That's our vertical resolution, or the number of pixels in the printable area, in this case the vertical dimensions. Or I'm sorry, the what we want is the logical pixels in the y direction. The number of pixels involved in a logical coordinate, and we multiply that by an original height. and we divide by 72 because that's gives us our logical inch. And we make the number negative, and that tells us that we have a logical coordinate. And finally, I'm going to add a variable for tracking our font, so we won't have to recreate it for each page. So it'll be a C font, M print font, and finally we can create the font from the logical font, log font structure. Now the other thing we need to do is determine how many pages we're going to print, and to do that we're going to want to know how many lines will fit on a page. So we'll again need the text metric structure, and before we can use that we need to make sure we select our new font into the device context. So we'll do that. And we're through with it. At that point we can go ahead and select the old font in. And we're going to add another variable to track the number of lines per page. And that'll just be an integer. Call it M and page lines. And we'll set that to again, we're going to call it get device caps, and this time we're going to pass vertical res, which is the number of pixels in the vertical, and divide it by our line height, which as before is the height plus external leading. And once we have that, we can go ahead and set our number of pages, and that's as we just set it to 1 in our other example with the circle. And this time we have 100 lines. Oops. Have 100 lines divided by the number of pages per line, and we need to add 1. And I know this is going a little fast, but the format of the video is kind of restrictive on all the things I can do here. Some of this isn't super precise, and some of it I don't have time to go into, but we're just trying to show a general approach to this. So one thing we need to do now is when we're done printing, we need to print or delete our font, so that we don't leave that line around, and we can just call delete object from the on-end printing. Now finally, we've set up to print here, and we're cleaning up when we're done printing, but our on-draw method in the view really is no longer going to work for this. And for this example, we're going to override the printing code. And so we'll go to our view class and go to our overrides, and the method we want to override is called onPrint, and that's called to print each page. And since we don't want onDraw to be called, we don't want to call the base class, so we get rid of that. So again, this is called for each page. So we do need to set the font again. And we'll use our font we created in on begin print. To get the line height again, and I need a couple of variables here as well. Basically, we're going to duplicate the logic from our onDraw. In fact, I'm just going to copy it over, save a little time. And let's just go ahead and run that and see where we're at. So our text looks the same as before. And if we go to print preview, we'll see it looks a little bigger now. And that's what we want. Now you'll see there's a few issues. First of all, we do know there's a next page. As you can see, the next page button is enabled. You can see it. I don't know if you can make it out, but it prints line 1 through 70, and then you can just see the top of line 71. And if I go to the next page, it actually shows the same thing because we're just printing the same thing over again. So we don't want to do that. So that's the first thing we're going to correct. So we need to get the starting line number and the p-info structure again contains the current page, and subtract 1 and multiply it by number of lines per page. And we'll set I equals to and start. Y will still be 0. And let's try that. Again, this is lines 1 through 70, and then the just barely part of line 71. If I go to the next page, there's line 71 through 100 that ends about the middle of the page. So that's about what we want. The only thing left really is at the bottom of the page. There is we really don't want to see part of line 71, so we need to cut that off. So we need another test in our loop. We need to stop when y plus the line height or rather we continue while y plus the line height is less than, and that p-info structure again has the a rectangle for the what we're drawing, and when it reaches the bottom. So we'll run that, and so this time we don't see a partial line at the bottom, just lines 1 through 70. Click next page, and there's lines 71 through 100, and that's basically what will happen, what I'll see if I print to my printer. And of course there's a lot more I could do. I could implement margins, which involves calling get device caps again and finding what part of the page is not printable, and then subtracting that from some margin value so you end up with a true margin. You'll do other things like perhaps you want to print a header and a footer, and a lot of things that I don't have time to go into, but hopefully these two examples will give you some ideas on how you can approach print and print preview in your own MFC applications.